Mark, and let's continue the third series of our IDCSE 0606 videos. For this series, I'm going to explain the unit, surds, indices, and exponentials. This is one of the shorter units, but there is still there are a lot of intricate knowledge that it's very important for students to master them. Let's look at surds first. So what is a surd? Let's look at what is a radical first, which is basically the root. So a root is basically any number with a radical sign. But a surd can only be an irrational number, which means that the roots cannot be simplified into simpler terms. For example, the root of 2, the root of 3, the root of 5, and the root of 6, they cannot be broken down into simpler rational number. However, for example, the root of 4 can be its will equal to 2. It is a radical, but it's not a surd in this case. There are also other property of surds. Surds can never be negative, so the root of anything will be equal to or more than 0. At the same time, the root of anything is only real if anything inside the root is equal or larger than 0. At the same time, when variables inside the root are undergoing multiplication, in this case, the root of AB will be broken down into root A plus root B. And by the same time, the root A and root B also both have to be equal or larger than 0 to make the surds a real number. At the same time, when dividing inside of surds, for instance, in this case, the root of A over B, it can be simplified into root A divided by root B. However, still, the denominator cannot be 0, so the root of B, so B must be larger than 0. Anything inside a surd cannot be lower than 0, so A must be greater or equals to 0. Let's look at some simple cases. So, for example, for this one, the root of 2 times the root of 3, the root of A times the root of B will equal to the root of AB, so equal to root of 2 times 3 equals to the root of 6. So now let's look at B. The root of 18 divided by the root of 6, which means the root of 18 divided by 6, which means the root of 3. Now let's look at some adding and subtraction of surds. When there is another coefficient in front of a surd, for example, 3 times the root of 3 plus 5 times the root of 3, then just as in a function, you add the coefficient together and combine the like terms. 3 plus, in this case, 3 times the root of 3 plus 5 times the root of 3 will equal to 8 times the root of 3. 2 times the root of 2 minus 5 times the root of 2 will equal to minus 3 times the root of 2. Let's look at the multiplication of roots now. For example, when squaring up a root, for example, in this question, 5 minus the square root of 2 squared. First of all, just continue as usual. A minus b squared will equal to a squared plus b squared minus 2ab. So 5 squared is 25. The root of 2 squared will equal to 2, as the root will cancel out. However, for 2ab, 2 will times with 5 and times with minus the root of 2. 2 times 5 equals to 10. 10 minus 2, the negative of root 2, equals to negative 10 times the root 2. So the final answer is 27 minus 10 to the root of 2. Now let's look at some surds division, a bit more complicated one. When you're undergoing the surds division, it is as the final product cannot have a surd in the denominator. So in this case, both the numerator and the denominator are times with the root of 5. So the numerator will be 6 times the root of 5, and the denominator will be the root of 5 times the root of 5 will be equals to 5. So 6. So with the integer denominator, this will be equals to 5, will equals to 6 to the root of 5, 6 times the root of 5 over 5. Same applies to here. When root of 7 is a denominator and 35 is a numerator, you times the root of 7 for both the numerator and the denominator. So if the numerator is 35 times the root of 7 is 35 to the root of 7. The root of 7 times the root of 7 is going to equal to 7. So the answer is going to be 35 times the root of 7 divided by 7. However, as 35 divided by 7 equals to 5, this can be further simplified, and as the numerator of 35 can be simplified into 5, the numerator of 7 can be simplified into 1, and the final obtained answer is 5 times the root of 7. Same as over here, and this question similar over here, but this time with other rules applied as well. Writing 5 over 3 minus the root of 2 with an integer denominator, as the denominator cannot contain any surds and roots, we need to remove the roots here. How do we remove it? This is a minus b. Remove it, we can times a minus b with a plus b, and then we can obtain a squared minus b squared, and the roots can be and the roots will be multiplied together, cancelled out, and then the denominator can be a real number. So in this case, 5 over 3 minus the root of 2. You multiply 3 plus the root of 2 for both the numerator and the denominator, because in this case 3 is going to be the first variable. The root of 2 is going to be the second variable. 3 is going to be a in the equation. Root of 2 is going to be the b in the equation. 3 times 3 will equal to 9, and the root of 2 times the root of 2 will be equal to 2. 9 minus 2 is going to be 7, and the denominator is going to be 7. Then you continue with the numerator. 5 times 3 is 15, 5 times the root of 2 is 5 times the root of 2. So the final obtained answer is 15 plus 5 for the root of 2 divided by 7. And this is called the radical conjugate. Similarly, for this question, we will need to times, 1 over 5 plus the root of 2. I ask you to write in the form of a plus b to the root of 2. So, similarly, you times with the conjugate 5 minus the root of 2 to get a denominator without the surds and the roots. 5 plus the root of 2 times with 5 minus the root of 2 is going to be 25 minus 2 equals to 23. The numerator is going to be 1 times 5 minus the root of 2 equals to 5 minus the root of 2. How do I write in this form? Writing in the form a plus b to the root of 2. In this case, each of the terms is going to be divided by 23. So 5 divided by 23 is 5 over 23, and minus the root of 2 divided by 23 is going to be 1 over 23 times the root of 2, as it asks you to write in the form of b to the root of 2. b is going to be 1 over 23. Now let's look at the indices. Some simple rules. A negative base with the odd index is always going to be negative, and negative base with the even index is always going to be positive. Now looking at some simple index laws. The a to the power of n times the a power of n, the power will add together. Then the final power will be a times a to the power of n plus n. When a to the power of m divided by a to the power of n will undergo subtraction, which will equal to a to the power of m minus n. But a cannot be 0, as the denominator cannot be 0. However, when a to the power of m is separated with the parentheses with the power of n on the outside, there will be a multiplication of a to the power of m times n. The base will be kept, and then the outside indices will be multiplied. And now in this case, when there is a power on the outside and two variables on the inside, each of the variables is going to be times with the power of outside. So a, b times with n, both will be times with n separately. A will equal to a to the power of n times b to the power of n. over here for division, when a over b will be times the power of n, it will be equal to a power of n over b power of n, as the powers will be powered separately with both of the variables. At the same time, any variable with a power of zeros is always going to equal to 1, but unless a is 0, as 0 cannot be powered, as 0 powered to 0 does not equal to 1. Also, for negative powers, when a have a negative power, and for any negative power of n, for any negative power n, it will equal to 1 over a to the power of n, and n will be the powers given. However, at the same time, a cannot be 0 because the denominator cannot be 0. Now let's look at the rational indices. So when a is in the power of 1 over 2, it equals to the root of a. Likewise, a to the power of 1 over 3 is going to be the root of a, the third root of a. And in general, a times any to the power of 1 over any power n, it will equal to the nth root of a for any real value. So now, based on that, you can determine that when a to the power of n divided by n, it will equal to the nth root of a to the power of n, with the value of n a positive real number, and with n at any real number. We can add some questions. So, for example, in this case, 2 times the third root of 2 is going to equal to 2 times 2 with the power of 1 over 3. And in this case, the fifth root of 4, as 4 can be as the root of 4, as 4 is 2 squared, it can be further broken down. So 2 squared will times with the 2 squared will times with the power of 1 over 5, as it's the fifth root, and 2 times 1 over 5 will equal to 2 to the power of 2 over 5. Also in this case, 27 to the power of minus 2 over 3, as 27 can also be further broken down into the cubic of 3. The power can be times as a to the power of n can times with n and equal to a powered n. So 3 will times with negative 2 over 3, which equals to 3 over, so that equals to 3 to the power of negative 2 equals to 1 over 9. So now it's some simple expansion rules. This is some simple equation to remember, and this can also be very applicable in further uses, especially in quadratics, and even further on in the calculus unit levels as well. So, for example, in this case, a times with b plus d is going to equal to ab plus ac. A plus b times with d plus d. Each of the terms will be multiplied at once. AC plus AD plus BC plus BD, as each term will multiply with each other at least once. When A plus B will times with A minus B, the terms will cancel out as there is one positive and one negative, so the final equation will be A squared minus B squared. And for the equation of A plus B squared, A plus B, and with everything squared, A will be squared, B will be squared as well, and then there will also be 2AB times. There will also be 2AB left in the middle, as A and B will be times twice, and as it's a power, there is going to be the same thing twice. Same with negative. A will be squared. B will be squared as the negative sign, as an even number, as the power is an even number. So the negative sign will turn to a positive sign. So it's A squared plus B squared. However, when timing the terms together, there is only a power of 1, so it's a squared plus b squared minus 2ab. Looking at some sample questions. So in this, for example, in this one, x times with the negative 1 over 2 power of x to the power of negative 1 over 2 times with x powered 3 over 2 plus 2x with the power of 1 over 2 minus with 3x over the power of negative 1 over 2. Each of the terms will be times 1 by 1, and as an times an equals to a to the power of n plus n, the powers will be added together. The powers will undergo addition. So minus 1 over 2 plus 3 over 2 equals to 1. Minus 1 over 2 minus 1 over 2 is 0, so 2x 0. So the constant term was going to be 2, and minus 1 over 2 minus 1 over 2 is going to be negative 1. As negative 1 also, as the coefficient times with the x of negative 1 also equals to the coefficient over x. As the coefficient is 3 in this case, the final equation is going to be x plus 2 minus 3 over x. Now look at the another question. 7 to the power of x plus 7 to the power of negative x when with everything squared. So first of all, 7, in this case, 7 to the power of x is going to be a, 7 to the power of x is going to be squared. However, am separated with the parentheses times with n is going to undergo multiplication. So the a squared term is going to be 7 to the power of 2x. For b, 7 to the power of negative x will be squared as well, and undergo multiplication for the power, and b squared will equal to 7 to the power of negative 2x. And now undergo the multiplication of two ab's. 2 times with 7 to the power of x times with 7 to the power of negative x, as the two powers undergo addition and they cancel out, so it's 7 to the power of 0 equals to 1. So the final answer is going to be 7 to the power of 2x plus 7 to the power of negative 2x plus 2. Now let's also look at some simple questions for factorization and simplification to factorize the terms. For instance, for this one, 2 to the power of n plus 3 plus 2 to the power of n. As 2 to the power of n plus 3 can be broken down into 2 to the power of n times 2 to the power of 3, and then plus the 2n at the end. The 2n are both of the two terms contains 2n, so 2n can be singled out, and the final equation is 2n times 2 to the power of 3 plus 1, as there's only 2n present in the second term. 2 to the power of 3 is 8, 8 plus 1 is 9, so the final answer is 9 times 2 to the power of n. Similar over here, 2 to the power of 3n plus 2 to the power of 2n. First of all, it's important to factorize, to identify as the same terms. 2 to the power of 3n can be broken down into 2 to the power of 2n times the 2 to the power of n plus the 2 to the power of 2n in the second term. And as the 2 to the power of 2n can be singled out, the final answer is going to be 2 to the power of 2n times with 2 to the power of n plus 1. And also two other ways of factorization. So over here, the equation is 4 to the power of x minus 9. And let's look at number 4 and 9 property first. 4 is 2 squared, 9 is 3 squared. Breaking it down, so to break down 4 to the power of x down, it will equal to 2 to the power of x with everything squared minus with 3 squared. As both of them contains a squared, it can be identified as a squared minus b squared, where the available equation a plus b times with a minus b. In this case, a is going to be the 2 to the power of x, and b is going to be 3. So the final factorization is going to be 2 to the power of x plus 3 times with 2 to the power of x minus 3. And now look at another equation, 9 to the power of x plus 4 times 3 to the power of x plus 4. Now look at the properties of these numbers. 9 is 3 squared, 4 is 2 squared, 4 and another 4, 2 squared as well. So breaking it down first, breaking down the 9 to the power of x first, to the 3 to the power of x squared plus the 4 times the power of 3 to 4 times the power of 4 times 3 to the power of x are going to stay the same, and the constant will stay. And now you're going to obtain a quadratic equation as 3 to the power of x can equal to another single variable. For example, you can set 3 to the power of x as a, and now the equation is a squared plus 4a plus 4, which a is 3 powered x. This quadratic equation can be simplified down into a plus 2 squared, and as a is 3 to the power of x, you input it into this equation with the final answer of 3 to the power of x plus 2, and with everything squared. And now let's look at some other ways to equate the indices, which is to broken down the numbers into its smallest base. So if a to the power of x equals to a to the power of a to the power of k, then x will equal to k. For instance, in this case, when 2 to the power of x is 16, and also 2 to the power of 4 is 16, x will be equal to 4. Now, with the more complex questions, examples, in this case, 4 to the power of x equals to 8. You break it, 4 is 2 squared, you break it down into 2 squared times x equals to 2 to the power of 3. So 2 to the power of 2x is going to equal to 2 power of 3. So in this case, 2x equals to 3 as the indices can be equated. X will equal to 3 over 2. So similar, apply it into quadratic knowledges. In this case, 4 is going to be 4 to the power of x plus 2 to the power of x minus 20 is 0. 4 is 2 squared. So to obtain the 4 to the power of x, you squared 2 to the power of x. To obtain, you keep, and the 2 to the power of x will be the new variable set in this equation, as the power is going to be changing. For this one, 2 to the power of x is going to have a power of 2, and then 2 to the power of x is going to have a power of 1 here, and for the constant term, the 2 to the power of x is going to have a power of 0. You set a, and then you set a as the 2 to the power of x, and then the equation is going to goes like a squared plus a minus 20 equals to 0. You break it down using a quadratic formula. A squared plus a minus 20 or equals to a minus 4 times with a plus 5. A equals to 4 and a equals to minus 5. Then you input the original value in. So a is equals to 2 to the power of x. 2 to the power of x equals to 4, and 2 to the power of x equals to minus 5. However, unfortunately, 2 to the any power cannot be a negative value, so unfortunately, the answer of negative 5 has been rejected. However, 2 to the power of x equals to 4, as 4 is to 2 squared, x is going to equal to 2. At last, let's look at the exponential functions. So let's look at the general trend of exponential functions. So for instance, looking at this one, 2 to the power of x, there's always going to be an asymptote in the middle, meaning the value is going to be will be close, will be approaching close to the value but never touch. And the intercept is the intercept is going to be 0, 1, x is 0, y is 1 for the original 2 to the power of x function. And as x goes smaller, y goes smaller as well, but will be always larger than 0. And as x increases, y will keep on increasing. And the y value will be the range of this equation will be positive infinity. So look at the general exponential functions, which is this equation, y equals to a times b to the power of x minus 3 plus d, where b is larger than 0 and does not equal to 1, as 1 to the power of anything is going to be 1. And also a cannot be 0 as the coefficient cannot be, as otherwise this whole term is going to be 0. The whole trend is observed and sorted. If a is larger than 0, b is larger than 1, the exponential function is going to be increasing. If a is larger than 0, but b is between 0 and 1, the function is going to be decreasing. If a is smaller than 0, but b is larger than 1, the function is going to be decreasing. However, if a is smaller than 0, but b is between 0 and 1, the function will increase, as b will control the steepness of the graph, and c will control the horizontal translation, and d controls the vertical translation of the equation, with the d as an asymptote that the equation will approach but never touch. For example, in this case, y equals to 2 to the power of negative x minus 3. Minus 3 is going to be the horizontal asymptote in this case, as it will approach to minus 3 very closely but never exceed the point. And also the y-intercept is going to be negative 2 by inputting the x value as 0. And also to draw a graph, you need to input another value of x. So in this case, a random x value such as x equals to 2 is inputted. You get a value of y as the value of y is negative 2 3 over 4. As you need 3 points to draw a graph and determine and draw with the shape, you need another point as well to make sure the shape of the graph can be drawn more correctly. X with the value of negative 2 is used in this case, but any value can be used there, as long as this is applicable in this scenario. So in this case, when x is minus 2, y is going to be 1, and with 3 points and its asymptote, also with the general shape, the graph can be drawn. The graph can be also used to estimate values based on the graph. And now let's look at the natural exponential and its trends of the original basis. If the base value is if the base value is lower than 1, the smaller the base value, the more steep the graph is going to be, while showing a negative trend. And when the base is lower than 1, but the larger it is, the less steep it's going to be. However, this is going to be different when the base is going to be larger than 1. When the base is larger than 1, the the more positive the base is, the more steep the base is going to be, as you may see in this case. When y equals to 5 to the power of x, the graph is going to be much more steep than y equals to 2 to the power of x. And now that is everything for this unit summarized with key non-reducible examples. I am Mark. This unit is finished. Congratulations. And thank you for watching as well. Remember to leave a like if you like it. If you have questions, feel free to leave some comments below. And we'll see you soon in our next series.